back to my channel. Today we're gonna work on the question shortest path in binary matrix. The question states given an n times n binary matrix grid, return the length of the shortest clear path in the matrix. If there is no clear path, return -1. A clear path in a binary matrix is a path from the top left cell 0, 0 to the bottom right cell n-1 and n-1, such that 1. All the visit cells of the path are 0, and 2. All the adjacent cells of the path are 8 directionally connected. They are different and they share an edge or corner. The edge of a clear path is the number of visited cells of this path. So let's look at example 1. Example 1, our matrix is 0, 1, 1, 0. And then as you can see from 0, 0 to the n-1, n-1 cell, which is here, there is a clear path, and that's why the output is 2. There's 2 steps, so 1 and 2. Let's look at example 2. Starting from 0, you can see we can traverse here, here, and here. So there's 4 steps. And keep in mind, we can only traverse to the cells that are 0. So here's a clear path, and the output is 4. And for this example, I think there's no clear path. It's like the first 0, 0 is already 1, so we couldn't go anywhere. We can only traverse on the path that it has 0. And let's start writing this. So I'm gonna try to solve this using a BFS, and BFS uses Q, so I'm gonna use the help from collections, import DQ. It's a double-ended Q. And then let's first figure out what's the row and column. Row is the length of the grid, and then column is the length of the grid 0. And then we can define our Q as a DQ, where we have a list of, we'll do DQ, we're gonna enqueue the first row, like the first element, right? So it's 0, 0, 0, 0, and then we'll also have a third parameter called step. So step is gonna be at 1 first. So if we start on the first one, there's already 1 here, right? And then this is the second one. So basically this means the row, current row and column, and the steps. The number of steps. And then we can define the directions. Since this is 8 directionally connected, we can do directions can be a list of lists. So it'll be 1, 0, -1, 0, and then 0, 1, and then 0, -1, and then 1, 1, and then -1, -1, and then -1, 1, and 1 and -1. I think these cover everything. So these would cover the nodes. I mean, let's look at a bigger one. So if this is our node, it would cover all these 8 directions. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And after we're done this, we can do some base checks. So what is our base check? We have to make sure our starting node is a 0 and our ending node is also 0, so they're open for the open path. So basically we can do a check like if grid 0, 0 does not equal 0, or grid row -1, column -1 does not equal 0, then we can return -1 immediately because there wouldn't be a clear path between them. And then after we're done all these base checks, we can start our BFS. So while Q, we can pop the row, column, and the steps by doing q.pop left. And then let's immediately check if it's already at the last step. So if row, column, if row equals the row minus 1 and column equals the column, C equals the column minus 1, then we can return the number of steps we took because we're already at our last node. And then let's see, now we can do for x, y, and directions, we'll go through all of these directions and update our new row equals new row and new column equals row plus x and column plus y. And then we have to do some checking for these new row and columns, whether they're unbound. So if it's greater or equal to 0 for this new row, and then also smaller than the row here we define the bounds. And if 0 smaller or equal to new column, and then smaller than the column here we define. And we have to check if the grid with the new row and column, new column equal to 0. And if it fulfills this, that means we can traverse to that path. Then to traverse there, we can do q.append new row, new column, and then we can add 1 to our step. So step plus 1. Steps plus 1. And then we don't want to visit it again, so we can mark it on our grid. So grid new row, new column, equals x. And then if we traverse through everything and then we haven't returned yet, we can just return -1. Oh, I accidentally used a comma here. Thank you so much for watching, and let me know if you have any questions.